Hi everyone, I'm Tracy and this is Sean. We are engineers from LinkedIn's hiring team. And today we're going to talk about how we build hiring agent using LangChain and LangGraph. That cuts time to interview by 60% for small business. Some quick agenda. So we will start by talking about why we need agent for hiring and why is that an agent problem. Then how we evolve and adopt to LangChain and LangGraph, and also how we evaluate it, and last, some lesson learned. So why hiring is an agent problem? When we talk to small business hiring manager, and oftentimes we hear that the biggest challenge is hiring takes too much time. And on average, they spend 9.5 hours a week just reviewing candidates and deciding who to reach out to. And for small team, like startup, that's already full days a week gone before any interview even happened. So that's why. And also, hiring is a loop. And it's not a one-shot task that you post a job and you get the perfect candidate. So you started with some job description, and you see who applies, and you start to realize some of your must-have requirement is actually nice to have, or vice versa. Then you have to modify your job description again and source more people, and then reevaluate your applicant list, and again repeat until you find the perfect candidate. And this is the exact shape of an agent problem. You plan, you act, observe, and adopt. And that's why we built hiring agent. And our process began with a simple guided intake, where our agent collects your hiring requirement and started with the job title. Then our agent will generate the job description for you. And once you confirm and posted the job, and our agent will immediately source some strong fit candidate for you to review. And you can either invite them to apply to your job or provide feedback to our agent so that our agent will align with your expectation from day one. And once you get applies, our agent will evaluate the applicant for you based on the qualification that you define. And you can also send like AI-powered screening interview to them, so you are saving time for meaningful conversation with the correct talent. And last but not least, you can always chat with our agent, ask any hiring-related question, or ask the agent to take any action on behalf of you. Now we have just seen how our hiring agent automated the entire process. We will talk a little bit more about the architecture behind it and how we evolve. We started with some static workflow where we use like scenario branches, if this, then that. And all the transitions are hard-coded. It works until our system becomes a little bit more dynamic. So we adopt to LangChain, where we implement toolchain with sequential execution. While this provides some partial abstraction, but still lack of the dynamic decision-making that we need. And our final breakthrough came with adopting LangGraph. And this is the true agent control model, where we have a central planner that drives a plan-execute-replan loop. And the key difference here is we use LLM for decision-making, which makes our system significantly more robust and adaptive. We just talked about how we shift to agent control model using LangGraph. And let's dive into some particle implementation. Our design have 3 key points. So first, we use a single agent with centralized reasoning. And instead of the rigid and trained process, now we have one core LLM-powered planner that's responsible for all the high-level decision-making. And this main brain will take care, make sure there's coherence and allows complex and multi-step problem solving. Next, we have our entire workflow operates on a plan-execute-replan pattern. And this is the dynamic core of LangGraph. And finally, we ensure continuous improvement through a closed-loop feedback and observability, which we will talk a little bit more later. And overall, our system is really simple, but backed up by strong tool and skill, we are able to fulfill all the requests from our user. So Sean, why do we pick LangGraph?
Great question. Actually, LinkedIn selected LangGraph among 89 agent frameworks after a thorough research and evaluation. So there are a couple of reasons. First of all, some agent frameworks don't provide enough low-level primitives. Some agent frameworks focus on areas that LinkedIn's infra already has. And LangGraph is the agent frameworks that complements with existing infra. Also, LinkedIn's agents already speak LangChain. We have runnables, tools, callbacks, and LangGraph builds on those primitives, not around them. So adopting the graph means zero rewrites for us. And last but not least, LangSmith. LangSmith has been deeply integrated to our day-to-day troubleshooting practices. And we look forward to bringing into more and more features and new products that's announced yesterday to our production, and that's amazing. So in conclusion, it's not only because of LangGraph itself, but also because of the whole ecosystem that's built around it. LangChain, LangGraph, and LangSmith, everything, which is amazing. And there we go. Next, I'm going to talk about how we integrate into LangGraph primitives within LinkedIn and how specifically our hiring agent does. So internally, there is an LinkedIn agent platform which talks to both LangGraph as well as our internal systems, including our messaging platform. So there are two types of memory persistence mechanism within LinkedIn agent platform. One is called conversational memory, which stores the chat histories. And that also talks to the messaging platform with the deep integration. Also, there's another one called experiential memory, which stores state checkpoints. And there's also some other memory applications built on top of that. For example, episodic memory and semantic memory to empower the memory experience. In terms of the skill registration, so LinkedIn agent platform allow different teams to register their own skills based on, for example, their teams or their business needs. And we specifically make use of the hiring intent skills, profile, evaluation, and applicant skills to achieve our functionalities. Middleware and hooks. So LangChain has such good stuff. So LinkedIn has already integrated to some extent, for example, PI detection, context summarization, and persistence. I know Deep Agent has already done this as well. And pre-tool helpers and post-tool formatters to ensure some determinism that we really want in our agent specifically, and I'll talk about it a little bit later in our lesson learning. So this is an LangGraph checkpoint schema that we're actively using within our agent. You can see besides input and output, which also includes the suggested prompts as part of the outputs, we also have a lot of context-related parameters, which are the key for our agent. So especially the context parameter itself, it has tons of parameters. For example, there are two main types. First one, it should be passed through the whole conversation or the whole thread, like hiring intent, job ID, applicant list, applicant IDs, that's global. And there are also a couple of parameters that only will be activated based on case by case. Like, for example, the pending learnings, a formatted pending learnings, once that's generated from the previous node, for example, it should be passed through to the next node within the context field. And this is what I told before, our LangSmith experience. Thanks to the LangSmith trace skill that is provided by LangSmith, we get a chance to integrate to Claude Code. That's how we actively use day by day, hour by hour, minute by minute to troubleshoot. So the real experience is a trace ID in and a root cause out, which is very powerful, straightforward, and convenient. So next is the agent evaluation.
So we just saw how we leverage LangSmith for deep observability. This is actually an essential step for the closed-loop feedback that I talked about earlier. And to understand how we use this data to make our agent better, we will talk about the evaluation process that we use. So it started with evaluating with LangSmith, capturing every trace that, or every interaction that it has with the agent, not just the final answer, but the full trace. The contact retrieval, the tool calls, and also like every decision step that we have. However, due to our linking policy, we're not able to send everything to LangSmith yet for our production data. So we built something similar or mirroring what LangSmith does. And together, we send those data into our human annotation and also LLM-as-judge, and which it will capture any nuances that the model might miss. And our final step is the optimize. And today, what it means is we will manually refine and retune our prompts and model to, based on what the annotation service. And the path forward is engine, which is what we just learned yesterday as well. And we're looking forward to integrate it and close our continuous learning loop without too much human in the middle. And for today, it's human-driven, and tomorrow it will be continuous. So we just talk about how our agent evolved and how we architect and design it. And along the journey of building this adaptive agent, we have some lessons learned, and which we want to share today. So lesson 1, LangGraph provide primitive, but product constraint determine the real architecture. So Sean just talked a lot about how we integrated LangChain's primitive and how they were useful and powerful. But however, not everyone fit into our use case. And the story behind this lesson is we have our agent watching recruiter works, and we want to make some suggestion. For example, it will say, looks like you are moving candidate without a degree in computer science to top fit. So is education requirement really a must-have? Will you want me to remove it? So what's next is the user could either say yes or no. But the interesting part is they could just walk away or completely change their topic to something else. And so our first instinct was using LangGraph's interrupt primitive. It paused execution mid-node, checkpoint the graph, and wait for the input from user, and resume to accept same spot. And this worked beautifully for long-lived graph and clean yes or no flow. However, it doesn't really fit our use case. So we built context-driven human-in-the-loop instead. So every input, we will run the graph end-to-end, and at the end of the graph, we will persist minimum cross-turn context. In the example that I mentioned, we will be storing something like suggest removing education requirement and waiting for users confirm. And when the next message come in, our planner will see, is it relevant to the suggestion? Do we want to confirm it, reject it, or pivot to something else, meaning we wait for the context to expire. With this approach, it gives us stateless scalability, full request tracing, and also keeping our conversation flexible. But most important is we control our checkpoint size. Instead of storing the full graph, we are just persisting the minimum context. And Sean's going to talk about why that is important to our agents and why we picked this path.
Yeah, models are probabilistic, as you know, but agents need to be more deterministic, especially for our use case, based on harness engineering. And as you all know, with the improvement of the model capabilities, a lot of the harness engineering efforts will be eventually replaced. We also believe that there are always some part of the harness engineering works can never be replaced, and that's the customization, and that's the differentiation, and that's how you make an agent succeed and shine. So I specifically want to share a few lessons that we learned on how to do the harness engineering to make our agent better and closer to our user requirements. So each agent has its own functional focus. So the priorities in harness engineering are really different. For example, coding agents focus on the code correctness, and they need to have more exploration capabilities to get to the final answer with trying different approaches. For example, a shopping agent, they need source grounding and safe purchasing action boundaries to secure the safety. And with the LinkedIn hiring agent, want to ensure the consistency of recruiter-facing action paths, as well as our trust compliance. So there are a couple of efforts. First, the context management, as we have been talking about all the time. So checkpoint trimming, history summarization, as well as context conflicts management. While different context providers have conflicts, we need to handle that. So this tells the agent what needs to be remembered. And output format determinism. So sometimes we want the agent to output something consistently across different runs. So we have template confirmation and fallbacks to output rather than LLM reformulation, programmatic response assembly, those tricks to help the agent know what the user sees. Last, node chain determinism. For example, what if after one node execution, I always want to make sure the next node is something certain rather than random. Rather than saying all the stuff within the prompt, we actually have a few parameters or tricks like state flag chaining, one-shot tool guards, which make sure one tool could only be called once or a certain amount of times, and signal-only tools, it can only be called within another tool rather than by the agent itself. So this ensures what agent does next. So based on all of the harness engineering, our agent is getting better and better and closer to our customer requirements. And that's something we're really glad to see. So overall, here's how we build our LinkedIn hiring agent. And thank you for listening.